Hello, welcome along. My name's Dan. Thank you so much for giving us a listen. In this episode, particularly, you need to get ready for your brains to be properly bursting by the end. We've got a chemistry special of the Fun Kids Science Weekly for you. We'll be learning all about it. You see, it's the part of science that looks at how matter is made, what it's made of. It investigates what it is and matter's reaction with other bits of matter. And we find out how new things are made. You see, everything in the universe is made of atoms. They're teeny tiny building blocks. Now, an element has only one type of atom. When they join together, they make bigger, more complicated things. We'll talk about this loads over the next couple of episodes. We've got 2 chemistry specials for you with a bunch of chemistry experts. We'll find out why glass isn't a solid or even a liquid. It's somewhere in between. That's on the way this week. You can also hear why really you're over 13 billion years old. And I've got some of your questions to answer in just a sec. First, let's get straight into it with our superhero friend. This is Kareena's Chemistry.
Kareena's Chemistry, with support from the Royal Society of Chemistry.
I was having a toy clear out because Dad said my dolls had more shoes than he did, and he was sick of treading on my building blocks. Can you hear me roll my eyes on radio? Anyway, I was getting properly bored with it all. So it was actually great that K-Mystery, my superhero alter ego, showed up.
Hiya! Oh, wow! You have a lot of toys. Let me help you sort them out. Chemists are brilliant at sorting things into groups.
What? Like dolls' shoes and building blocks?
Oh my gosh! Chemists love building blocks. Not so mad on dolls' shoes. Cute shoes, though.
Well, help yourself to the building blocks.
Nah, not those bobbly plastic ones. I mean real building blocks. Want to have a look?
Beats tidying up, I guess.
Let's find some elements. They're like the big building blocks for all the stuff or all the substances in the universe. So we'll have to get pretty small. Smaller than a molecule. There's 118 different types of elements. And they're just the ones that we know about.
118? That's loads.
Not really. I mean, those 118 blocks make up everything you can think of. From your dad, to dinosaurs, to dolls' shoes. Oh, maybe over here. The clue to whether a substance is an element is that when you look inside, all the tiny atoms are the same. I reckon this substance is an element. Let's dive in.
Ah, sweet. The atoms in here are like little planets with moons whizzing about. And there's hundreds, perhaps thousands of them. And it looks like every planet has exactly the same amount of moons going round. Weird.
Yes, I knew it. So this is definitely an element. Atoms all the same? Check.
So, what are those moons?
Those moons are the electrons flying around the protons and the neutrons. Chemists keep track of the elements by counting the number of protons in the atoms. That number is known as the element's atomic number. For example, all these atoms have 1, 2, 3, 4, 5, 6, 7, 8 protons. So they're of the chemical element oxygen. It's a pretty cool element, one of my favourites.
Yeah, well, oxygen is pretty important for breathing and stuff, so it's definitely one of my favourites too. But what's the point of the atomic number? Why not just call it oxygen? You know, like, hey oxygen, looking pretty good over there with your 8 protons.
The number helps chemists align it up on the periodic table.
Wouldn't it just roll off?
Very funny. Not an actual table. It's a chart, which is like a big sorting box of all the elements. Where it is on the table tells you a lot about what it's like, because lots of the 118 elements have things in common.
So there are only 118 types of elements, but there are squillions of things in the universe. How does that work?
It's like your building bricks back in your bedroom. There's only about 10 types of brick, but you can make them into anything you like by joining them together into different molecules. Have a look at this one.
The oxygen atoms are joined up in threes.
When atoms join together, then they make molecules. 3 oxygen atoms together make an ozone molecule. It's an important part of our atmosphere on Earth. They don't have to just stick to the same sort of element, though. Molecules can mix things up a bit too. Over here, I think. Here we go. In this substance, oxygen atoms are holding hands with 2 hydrogen atoms. And as it's a mixture of different elements, it's known as a compound molecule. If we zoom out a bit, you might recognise it. Hey, it's water! You've got it! H2O is water. Now that isn't a trick your building blocks can do, is it?
Definitely not. So, what else can the elements make?
Kareena!
Oh, that's Dad. Gotta go. Well, I suppose I should count myself lucky, but I only have to sort toys into boxes. Sorting the elements would take a lot longer.
You'd have a lot more fun, though. Well, that's what I think.
Well, OK, I'll give you that. Bye for now, Chemistry.
Kareena's Chemistry, with support from the Royal Society of Chemistry. Find out more at funkidslive.com.
We'll get back to proper chemistry in just a sec. First, it's my favourite part of the show, really, when I get to become like a science Sherlock. I do all the digging, all the investigating. I find the answers to the questions rattling around your brains. Your brains. The ones that you've sent over to me through the Apple Podcast Store. This is from Red Cardinal. Red Cardinal, nice name, is from America, and they ask, how do stars get their colour? Well, colours are all made of different light waves, and these change, and they make different colours depending on a couple of different things, and that's why we see them differently. Stars shine because there are nuclear reactions going on deep inside the stars, and these reactions make energy, which give off heat, which make the star shine. It gives us the light. Now, the temperature of the star can change the wavelength of the light, which then gives it a different colour. Also, if there are elements in the atmosphere around the star, that will change the way the wavelengths reach our eyes, which will change the colour that we see as well. Thank you very much for that, Red Cardinal. This is from Elodie in Ireland. Elodie asks, why kids' eyelashes are longer than grown-ups? Elodie, here's the thing. I've done quite a bit of research about this, and I'm not sure that they are. I think eyelashes are pretty much the same size for everyone, but what happens is a grown-up's head is much bigger than yours, which makes the eyelashes look smaller. It really is that simple. Also, Elodie, your brother Brendan wants to know if you can go to space in an airplane. Now, I know that there are some companies that are looking at getting you quite close to space in an airplane. For instance, I think like the Virgin Airline company, Richard Branson's one, I think they're making like a half-rocket airplane, which kind of gets you higher up enough for it to make you feel like you're in space, but you're not absolutely there. The thing is, for a regular airplane, the one that you use to go on holiday, for that to get into space is tough because of gravity. You need to travel extremely quickly to escape the force. According to NASA, any vehicle trying to launch into orbit has to travel at 7 miles a second. That's 25,000 miles an hour. And planes don't travel nearly that fast. Also, there's a little fuel problem as well. The shortest distance between Earth and space is 62 miles straight up. Now, rockets need 520,000 gallons of propellant to get them straight up there in 9 minutes, and there's no way near enough space in that for a regular plane to carry that much fuel. So, Brendan, no, you can't really get into space in a regular airplane. But thank you very much for the question. If you've got one that you want answering from me, you need to leave it as a review for the Fun Kids Science Weekly over on Apple Podcasts. It's the Fun Kids Science Weekly. We've got a chemistry special this week, and on the line now, Hannah McDonald. She's from the Biochemical Society. Hey, Hannah.
Hello.
I think I'd just start with, when did you realise that you wanted to study and then work in chemistry?
I think I first realised how much I enjoy chemistry when I was about 15. So definitely at school. And yeah, it was, I happened to be lucky and have some really excellent chemistry teachers, and just kind of fell in love with the way it affects everything around what we do and everything you do every day, and cleaning and cooking and everything, really.
Well, let's expand on that then, if we can. How does it affect things that we do every day? I guess the question is, what is chemistry?
So I would say chemistry is everything, and I know that a physicist would disagree and would claim that physics is everything. But well, we're all made up of atoms and molecules, and the way that they interact and the way that they build bigger structures kind of governs everything that we're made of, everything we do, all the different interactions that we have. I think some of the ways that I always find it really funny when things say that they're chemical free, because we're all chemicals really. So I mean, we're all made of chemistry. So does chemical free even mean?
Now, in terms of the fundamentals of chemicals, everything's made of a particle.
Yeah.
How able are you to talk us through particles? So, you've got a nucleus and then you've got protons and electrons around the outside. What are they actually made of?
Good question. So you've got your protons and neutrons, which are actually made up of even smaller particles than those, but they join together, and the number of protons and then the number of electrons which are in a particular atom help determine its properties and how it might react with a different atom or element.
And we were talking about how, you're kind of curious, sceptical of anything that says it's chemical free, because chemicals are around us every day. And you mentioned cooking and cleaning. Yeah.
So for sure. So if you look at, say, lots of things are, at the moment is quite trendy and fashionable to have natural-based cleaning products. So you can make your own cleaning products using vinegar with some lemon in it. But essentially all that is using the acid that's in vinegar as a cleaning product, as you might use a sort of a synthetic or lab-made acid or other cleaning product, rather than vinegar, which we don't necessarily think of as a chemical because you also have it on your chips.
So why do scientists synthetically make these when quite a lot of it is around us anyway?
So, I mean, one of the things that I always think is amazing about science, and one of the first sort of science books I've read when I guess I must have been about 15, 16, was about how science takes its inspiration from nature. For example, looking at materials that you have in the natural world and then trying to replicate products that nature can sometimes make really easily, but we have to work a bit harder to try and get those amazing products. But we can also use nature as well. So trying to think of an example, using enzymes and things. So if enzymes are molecules that are available, big proteins that we have in nature that essentially just speed up a reaction, which in chemistry you might call, is often termed a catalyst. And so an enzyme can be used very specifically to make, to speed up reactions and make a particular biological product.
Sometimes when we learn chemistry in school, it can be quite dry. You said that the way you were taught it really lit the fire for this. How do you think we should be engaging everyone as to the wonders of chemistry? Where's the best inland? Where's the best way that we get in so everyone knows just how fascinating this subject is?
So I guess a bit like what we've touched on already is relating it back to things that we know and things that we see is really helpful, and I find that really engaging because it makes it so much more real for me and less abstract. I also think, I really like puzzles and working things out, and I think there's bits in chemistry that are almost patterns, and you can sort of, it's a nice balance, I think, between some things that you have to learn and remember, but also some principles that you can learn one thing and then apply it to lots of different scenarios to try and guess how things are going to behave. And I think just once you kind of get your head around the fact that there's molecules that you can't see that are really small and that just look like sticks and letters when we represent them on a page, and then trying to look at how those different molecules will interact together to then create bigger structures themselves. I think that there's a lot of kind of work being done in that area to use very small building blocks to make bigger materials based on the very little interactions that they have that we can predict.
Lastly, we're doing this today. We're asking everyone this. What's your favourite element?
My favourite element is boron. Because even though I've not worked with it that much in my own research, when I was learning about it at university, it is the way that it bonds to other elements gives its compounds some really interesting properties and structures. So it's very exciting.
Amazing. Well, Hannah, thank you so much for telling us all about it, and good luck with your future investigations.
Great. Thank you very much.
Kareena's Chemistry, with support from the Royal Society of Chemistry.
So embarrassed. We had food technology today, and I thought I'd impress everyone with my double mocha choc cake with puffy mallow icing. I overcooked it. It exploded. It went everywhere. In my hair, in the teacher's hair, and let's just say Super Smug Sasha's perfect flicky hair is, more like, well, sticky hair now.
What's up? Is that cake in your hair? I really don't want to talk about it. Look, I'm not sure I'm in the mood for a chemistry superhero alter ego right now. Chemistry is all about clever people doing clever things. I just don't think I'm having a clever day. Maybe you should come back another time.
Hey, look, you were experimenting, trying stuff out. That's just what chemists do. Come on, I'll show you you're in good company.
I think if it's all the same to you, I'll stay in my room forever. It's bound to be safer, and that way I can't make a total idiot of myself in front of the whole class again.
Let's take a little trip through time. Don't worry about your hair. It's, fine, really. We're going back 2,000 years. Chemistry all started with the alchemists, and as the word alchemist is Arabic, that might give you a clue about where it all started. You know the word elixir?
Yeah, it means like a magical solution?
Well, that's an Arabic word too. Chemistry and magic were all mixed up here. This part of the world has a long history in being interested in how the world works. Okay, it wasn't just in Arabia, but from the beginning of time that people have wondered if the things around them, the soil, rocks and plants, might be able to give them answers to the mysteries of the universe, like how to live forever or how to make gold.
Wow, those sound like way cool experiments. So how did they do it?
Look, this alchemist here is mixing eggs and cinnamon and dung. He thinks it will make gold.
Phew, smelly. So did it work?
Of course not. Yeah, they might have had some pretty rubbish ideas. They used loads of weird ingredients like dung and ash, but they were just people curious about the world around them. As time went on, they even found out some useful things. This is Robert Boyle. He was around in the 1600s, 400 years ago. He was as curious as any of the chemists or alchemists that went before, but he was, well, a lot more sensible. He was really good at taking careful notes for starters. When he did experiments, he made sure he wrote down exactly what he had done, so he'd know whether it was worth doing again.
Well, that's something I'm definitely doing the next time I even think about making a double mocha choc cake with puffy mallow icing. I just won't bother.
Maybe you just need to tweak the recipe a bit. Oh, I know another famous chemist. We have to go to revolutionary France in the 1700s to find him.
I don't think I like it here. So many people, and they're all very angry.
Lavoisier was around at the time of the French Revolution. He thought scientists should agree names for chemicals and worked out that you can't destroy chemicals, just change them. Bit of a pity they chopped his head off, really. Think what else he could have come up with.
Ew, poor guy. I thought people would be impressed with clever chemists, not want to cut their heads off.
Yeah. And don't feel bad about making mistakes. All sorts of things were invented by accident. Let's visit a factory in the 1930s where they're making paper, but it's about to go a little bit wrong.
Whoops! What happened?
They dropped too much starch into the pulp by accident. But guess what?
It ended up making tracing paper.
Cool. Hey, my recipe for double chopped mocha with puffy mellow icing might make a terrible cake, but maybe it will make a brilliant glue.
Now you're thinking like a chemist.
Kareena!
That's Dad. Thanks for cheering me up. I suppose chemists are just, well, people like me, really.
You got it. No superpowers needed at all.
Well, chemistry. If a girl's got to have a superhero alter ego, then you're the best. Now, if only I could get this double mocha choc out of my hair.
Ah, thanks, Kareena. And remember, chemistry is all around us. A bit like that cake of yours.
Kareena's Chemistry, with support from the Royal Society of Chemistry. Find out more at funkidslive.com.
Now, normally at this part in our show, we do a Dangerous Dan learning about something devastatingly deadly. But for this week, for our chemistry special, I thought we'd do something just a little bit different. You see, it's such a big subject. There's so much that we need to learn about. I thought we'd quickly rattle through some of the best bits with some quick chemistry. Did you know glass isn't a solid? It's almost a liquid that just flows extremely slowly. In glass, the molecules inside still flow, but they flow at such a slow rate that you can't notice. It's not even enough really for scientists to class glass as a liquid, but it's not a solid either. Instead, it's somewhere in between the two. Chemists, they class glass as amorphous solids. Speaking of water, did you know when water gets cold, it does the complete opposite to most other things? You see, when something is cold, normally it shrinks because temperature describes the vibration of atoms. If it's hot, they vibrate a lot more and they take up space. When it's cold, they do the opposite, except water. When water freezes, it releases energy to create extra strong bonds because of the gaps between them. This creates more space, so it expands, and get this, hot water freezes much faster than cold water. Also, every hydrogen atom in your body is 13.5 billion years old. At ground zero, in the very first moments of the universe, the first chemical element made was hydrogen. All the hydrogen created was most likely made at the start of the universe, scientists think, which means that you are pretty much as old as the Big Bang itself. And finally, for our quick chemistry today, Mars is the red planet because of iron oxide. It is covered in the stuff. They're the same compounds that give blood and rust their distinct colour. So the abundance of iron oxide on Mars makes it look red. Right, let's get some chemistry that has been in your news. Now, you may think that snowflakes are tiny, but new research shows that the smallest nanodroplet of water in which ice can form is much smaller than a snowflake. It's only as big as 90 water molecules, which is about the 10th of a size as a virus. Also, the Nobel Prize for Chemistry 2019 has been awarded to John Goodenough, M. Stanley Whittingham and Akira Yoshino, who share the prize for their work on rechargeable devices for portable electronics. They can be found in everything from electric cars to bicycles, and Professor Goodenough is 97 years old. He is the oldest ever Nobel laureate. And finally, a team of scientists have completed a study to find what makes the stretchiest bubbles of them all. Jesse Burton and his team carried out loads of experiments to measure the thickness of the soap film using infrared lights to see which was the stretchiest. They found that polymers, which are a string of molecules, make the biggest bubbles, and one called Guam was the best of them all.
Kareena's Chemistry, with support from the Royal Society of Chemistry.
It's my mate Freaky Freya's birthday, and I've got her some ferret fridge magnets. She loves ferrets. Trouble is, just gave them a test, and they're not sticking to our fridge. Help! It's a chemistry conundrum. I said it's a chemical conundrum. Chemistry? This would be a pretty good time for a chemistry superhero alter ego to show up. Sorry.
I was just waiting for my cape to come out of the tumble.
Ah, cute magnets. Freaky Freya, right?
The ferrets gave it away, didn't they? But there's something wrong with the magnets. They're not sticking to the fridge.
We should take a closer look at those magnets. We need to get much smaller. Although, just being small isn't going to be enough to see what's going on here. If there's a problem with the magnet, we'll need to see the magnetic field.
Hey, crazy! It's like there are roads travelling in what looks like curves from one end of the magnet to the other. So where's the field?
All these roads are the magnetic field. One end is the North Pole and the other is the South Pole.
Oh, just like the Earth has a North and a South Pole.
Exactly. And if the magnetic field is really big, with lots of roads close together, then the magnet is a really strong one. If there are only a few roads, well, let's just say your magnet might fall off the fridge.
But my magnets are falling off the fridge.
Doesn't look like it's caused by the magnetic field here. It's pretty busy here.
So how does that magnetic field make the magnets stick to other magnetic things? It's just, well, waves of stuff whizzing from there to here.
You see how the roads all go the same way?
Yeah, and they're in a hurry.
Yes, and they love a shortcut to get to the opposite pole. Check out what happens when you put the south pole of a different magnet close to the north pole of this one. Let's move out the way.
Oh, they've crashed together. I wouldn't have wanted to get squished in the middle of that.
Me neither. See, it's a lot quicker to hop from this north pole to that south pole. That's why magnets stick to each other and magnetic materials. It's just a shortcut to where they want to go.
But what's creating the magnetic field in the first place?
It's not an easy one to explain. So let's get down with the molecules.
Cool, spinny moons. I mean, these are the tiny atoms, aren't they? The moons are the electrons.
Well remembered. How many moons? Electrons, can you see?
Going really fast. Most of them are travelling in pairs. Hey, look, 4 of them on their own. Ah, poor lonely electrons.
The teeny tiny electrons carry the mysterious force that is responsible for stuff being magnetic. It's created by even tinier particles called quarks and leptons. They're seriously weird.
They sound it.
And don't feel too sorry for the ones on their own. They have a special job. They push the magnetic force out of the atom, and when enough of the same type of atoms line up in the same direction, like these atoms are, then you get a magnet.
So why isn't it sticking to the fridge door? I thought magnets stuck to all metals.
No, not all metals. Only a few. Iron and steel, that's made from iron, nickel too. They don't have magnetic fields of their own, but they get pulled towards magnets. Let's go down and check out the fridge door. Kareena, have you ever noticed that your fridge door is made of plastic? It isn't made of magnetic material at all.
You're joking. Oh, wow. I have to admit, I feel pretty stupid now. It was the fridge that stopped the magnets from sticking. Although, it's pretty stupid calling them fridge magnets if they don't stick to fridges.
Kareena!
That's Dad, I gotta go. At least I can wrap up the magnets for Freaky Freya now. I'm sure she'll love them.
She should do. They're ferrets, and they're her favourite freaky thing. See you later.
Kareena's Chemistry, with support from the Royal Society of Chemistry. Find out more at funkidslive.com.
And that is it for this week's Fun Kids Science Weekly. We're back with another episode next week, another chemistry special, focusing all about the periodic table and all the elements inside. If you want to know more about chemistry, by the way, there are so many amazing resources on the Royal Society of Chemistry's website section for International Year of the Periodic Table. To find that, you need to go to www.rsc.org/IYPT. You can also find out more and hear loads of the science series that we do on Fun Kids. You've heard some today. We've got loads more for you over on Apple Podcasts. They're on the free Fun Kids app and at funkidslive.com. While you're on Apple Podcasts, it's the best place for you to send me in a science question. Just leave it as a review for the Fun Kids Science Weekly. And Fun Kids are a children's radio station from the UK. You can hear us all around the country on your DAB digital radio on that free Fun Kids app and at funkidslive.com.